That kind of leads me to what was going to be our presentation for this month, but instead it's going to be kind of a little more show and tell with some of the stuff I'm working on. Give me one moment. I'm talking too much. If I am going too fast, please let me know in chat. So what I wanted to talk about this evening was upstream plus kernels. What does that mean? So we're at a point now where some of these boards do have an amount of their capabilities upstreamed into mainline Linux kernel. It's not complete. Um, many of the, for basically all of the boards, the processors work. But that's not necessarily helpful because just the processor working means that you can get to a point where the kernel goes, oh my goodness, I can't find any RAM and explodes because it doesn't necessarily have support for the memory controllers. Um, but there are in-flight patches for many of these boards that support most of the peripherals. There's two primary kernel trees that I have been tracking that are capturing a lot of this in-flight work. One of them is a tree from the REVI-OS team, which is out of China, and the other one is John at Red Hat, who has put together an automated system that pulls all of these in and makes multiple trees available for different types of targets for the kernel. So he has one for the EIC 7700. He has one for it's a combination of three boards. It supports the TH1520, the Vision 5.2, and some other board the slash SOC that I've never heard of. And he has a few others that I have been tracking. What I have started is a repo on Codeberg, where I am linking to all of their kernels as submodules. So you can check out the one that you want. You will also be in the exact same commit that I'm using, which is beneficial because, like I said, these are tracking in-flight patches. So there's going to be differences other than the released kernel on kernel.org for some of these. Um, and I'm specifically making configs for a bunch of the different hardware that I have here trying to get up and running. And so that's mostly what I wanted to talk about was my experiences with these so far, how this has gone, how I'm building it, things of that sort. So right now I'm building all of this natively on my deep breath, the Sci5 Hi5 P550 Premier. That is running Debian. It is running a slightly different kernel than the one that it ships with, but it's running a Debian user space, and I've been doing all of my compiles on that just to make it natively. That's been a lot easier than dealing with cross-compiling from other operating systems or even running it in emulation. My experience so far is trying to do compiles in emulation has been very slow. There's something up with QEMU where process startup times are very slow. Once they are running, they're relatively fast, but the process of getting them started is sometimes painful. So let's talk about the boards that I've been working with. The first one has been targeting the T-Head 1520. My target board for this is the SciPy Lychee Pi 4A. As I noted earlier, this has got the same integrated GPU as the upcoming K3, and that's part of the reason why I want to do testing and debugging with that. One of the things that I found is that there are major differences between the device tree that ships with the vendor kernel and the device tree that is in the vanilla kernel tree. The kernel, if you use the device tree that comes with the kernel from John's tree, that will boot, Ethernet will work, Serial will work, eMMC will work. USB doesn't show up at all. And I don't know why, and none of the display components seem to function. The REVI-OS kernel, I can get the display components to function. I can get the USB roots to show up, but I can't get any of the USB hubs behind those roots to show up. That seems to be something to do with the device tree. The other problem is on both kernels, only one processor core comes up, and it's very slow. I'm currently doing some testing where I'm running those kernels with the vendor device tree because there's so many differences between them. It's probably a bad test, but it's just where I'm starting. And one of the immediate things that I discovered is like the vendor device tree says that the processor supports vector, and so the kernel starts doing all of its tests to see whether or not vector is going to work. And spoiler alert, it's using vector instructions that are not in the XT head vector extension that's installed as opposed to the final vector extension. So I've just completely disabled vector in these kernels for the most part. I don't really care about it for my use case. It's not Vector 1.0. Any of the things that I'm trying to do are probably going to be much more interesting using Vector 1.0 when we get the either on the K1 or the K3. Um, but for right now, it's not that big of a deal. Um, so I'm doing more testing on that. I built another curler earlier. I've been in a lot of meetings today, and I also didn't get all of these slides done last night. So I spent a lot of time doing that. My point is the REVI-OS kernel seems to be the most complete. The configs that I'm currently using are actually in the repo already. If you want to go check it out, feel free to look at it. Once I have things put together, I am actually going to make binary packages available and update our wiki with instructions on how to get these kernels on, how to use them with different user spaces, be it Fedora or Debian or Arch or kind of the big ones that I work with. If folks want other ones, please let me know. I'm happy to look at them. But that's where I'm at with the TH1520. I know that the integrated GPU stuff should just work, and I know that and I'm primarily targeting Arch because I want to get the latest greatest Mesa, so that I can try and get things up and running. My understanding is that Zinc should be usable now, which is really exciting. So I'm curious to see what that's going to look like on a relatively fast core, um, even if it doesn't have vector. I'm excited to see what that looks like with a reasonable UI interface that has full blown GL through Zinc. And if you don't know what Zinc is, feel free to reach out. I'm happy to dive into all of that in the Q&A section or in a future discussion. The other one that I'm going to be working on is a newer kernel for the K1. So our websites are actually running on a Banana Pi F3 sitting in a data center, and it's using the vendor kernel. I'm not that worried about it because all of our websites are static. So even if someone does compromise it, it's really easy for me to completely rebuild it by just uploading the code again. And it's just HTML. Like I don't even have PHP or anything installed. That's fine. So my goal with this is to try and get um, something up and running kind of for that use case. Target boards are going to be the Milk 5 Jupiter because I have one here, and the Banana Pi F3. Um, I'm not trying to get any of the discrete GPU stuff working. I've burned months trying to get any form of a discrete GPU working on the Milk 5 Jupiter. I've tried with Oculink on the by16 slot. I've tried with Oculink on the M.2 adapter. None of it has worked. I've tried adapters with redrivers. It's a mess. And even then, the only thing that you would be able to get working is the older Radeon HD graphics cards. You have to use the old Radeon driver, and there's a bunch of patches to it, so it will operate in the 32-bit only mode. You can't apply those patches to the AMD GPU driver, so you're going to be really limited anyways. I've even tried crazy things like getting IBM made a Matrox card for power servers. That's a Matrox 550 with two DVI ports on it. And I can't even get that to work correctly. So, and that's got a very low power load on it. And that's really been the problem with the Jupiter board is that there's just not enough power run from uh, the ATX slot to the PCI Express port in order to power a larger GPU. So haven't had much luck there. Kind of ignoring it for the time being. It's possible that somebody is going to tell me the magic sauce that they have done because I've seen a lot of YouTube videos of people making this work, and I just haven't gotten it myself. So I'm kind of targeting more server compile farm type workloads. Vector is going to be enabled. NVMe is important for me on there. I'm tracking the REVI-OS and John's trees for this. I'm just getting started on this, so I don't have any of the configs in there yet. I've been focusing mostly on the TH1520 for right now. And also the next part that I'm going to talk to you, but this is the next big one on my list. try and get that up and running with a relatively modern kernel, and get some more bits and pieces working there, and then go upgrade the one in the data center. And if I can get that working by this weekend, I'm hoping to actually do that upgrade this weekend, which would be great. Um, the last one is the EIC 7700. So my target boards for this are two of the three that I have. That would be the Pine 64, Star Pro 64, and the Milk 5 Megres. I'm not trying to do this on the P550 Premier right now, just because I have a working one and it's doing most of what I want, so it's not really a big deal. But those two boards, there's very big things that I have planned for some of those. So the Megres is one of the boards that I want to take to scale, and I want to have a much newer kernel than what's on it. And then the Star Pro 64s, I have a stack of them, and the goal is to get them into the data center as a build farm. 3 of them are going to be a cluster, and 3 of them are going to be generally available for plugging into a CI system and for folks to be able to access remotely to go do builds on without having to go jump through all the hoops of getting stuff up and running. I'm working with the folks at 10x Engineering and trying to get these integrated into their Cloud V initiative, so that these can be available for folks to do stuff on. We need more compile time inside of the RISC-V ecosystem is what it boils down to. And that's my goal with this, is to get 6 of these up and running, available for the general public to be able to start doing compiles on. We'll have containers and stuff in place. We'll put together a CI build system that can plug into different things. They already have things for GitHub and GitLab. I'm actually going to go spin up an entire Woodpecker CI system that can be plugged in for doing that, and then we can tie that into other projects as people need it. But the goal is just to make it work. And getting everything except the P550 has been really hard on these. The P550 has a very different architecture than any of the EIC 7700 boards. The P550 has this weird ST micro kind of baseboard management controller, although it's not really, but it is. And that deals with powering on and off, resetting the CPU, doing various other functions, and those don't exist on the Pine 64 or the Milk 5 boards. So there's some pretty serious differences there that have been causing me all heck trying to get kernels built for them and coming up and working. I can't even get serial output on them currently. I think what I'm going to wind up having to do is the same trick that I'm doing on the TH1520, is use the vendor device tree to get started to just see if I can get any messages out of them when they're booting over the serial port. Like, getting a kernel panic is a win at this point. Right now, I get to the point where you boot completes and then it hands over to the kernel and nothing happens. So I'm trying to piece together what's going on there. It's possible that SBI isn't running correctly. It's possible that it's expecting that SBI be in the kernel. I haven't figured all that out yet, but that's part of what I'm trying to get to. Once I do get a kernel working, though, the internal GPU is not very well supported on these. At best, we'll be able to get a frame buffer, which is not particularly useful, and I don't really care. On the machines that I do have working, I basically ignore the onboard GPU anyways and just use discrete GPUs with them because the software support for that is much better. So I typically run them with an RX 5500, an RX 6600, or an RX 550 in them, and I run out of CPU before I run out of the GPU with all of those. I can do all sorts of fun stuff with it. So the goal there is to be able to make these work with discrete GPUs, or just completely headless, like a server for build farms and things like that. I'm not super focused on trying to get the display controller and the frame buffer working to make the HDMI ports work. I believe that's using the VeriSilicon DC8200, which is the same thing that's in the T-head and will be in the K3, but don't quote me on that. But again, not really a priority for me at the moment. If we can figure out how to make it go pretty easily later, great. But I also expect that there's going to be some patches to it because there always has to be. For that display controller only spits out embedded DisplayPort, and all of the boards have HDMI ports on them. So there's something in between that's doing the conversion between the embedded DisplayPort and the HDMI. And that's typically where we need patches to make things go. I know the drivers that are in flight with the kernel right now have specific patches for the TH1520. I expect there's going to be some for, and also there's patches for the way the HDMI implementation is done on the Vision 5 too, because that also is a little bit weird. But that's what I'm trying to dig through on here. Right now, obviously the problems that I'm having are, again, related to device tree. Not entirely sure what yet. Um, I've kind of been focusing on the TH1520 the past couple days, and I've only been working on it like in between meetings at work, so it's been difficult to try and make progress. But hopefully we'll have something there. Again, everything I'm doing is on that GitHub repo. If you go to Codeberg slash EDOLNX, there's only a couple repos in there, and one of them is RISC-V SBC kernels. I have the config broken out in there. I have a status text file that tells you which one. The kernels are linked as submodules in the source directory, so you can just check out the one you want. And again, you'll be at the exact same commit that I'm at. As I update them, I will let you all, I will update those hashes and whatnot, update the status files and so on. Feel free to follow it there on Codeberg. Um, and that is the vast majority of what I had today. I know there are some folks typing in chat. I would love to answer your questions.